from a cosmic singularity. Probably all of you know this, the Big Bang. But instead of thinking of it as like a giant and violent explosion like TNT bleeding out, it was more like a giant balloon inflating. So ever since its birth, all the stars, all the planets, or ourselves, all have our beginnings in the Big Bang. A billion years after the Big Bang, stars were forming. The first stars in our universe were really massive, about 2,000 times the mass of our sun. And these would have only have lived a few million years before they would have died and went into a meganova, which is a cosmic explosion. So these created the heavy elements. But when these first stars were forming, the only elements we have are the ones we know as the lightest, hydrogen and helium. There was traces of lithium, but no other elements were virtually present at that time. But these meganova explosions produced a whole new range of elements in the periodic table. And these supernova explosions as well, they also created most of the heavier elements all the way down to the bottom, completing the periodic table. So 13.5 billion years ago, our Milky Way galaxy formed, and it was one of the first spiral galaxies. All this is known by one astronomer. His name was Edwin Hubble. He discovered that the universe was expanding, and so he named the types of galaxies that there were. And so he believed that the first galaxies were elliptical galaxies. Some people believe that elliptical galaxies are old galaxies, and they are. They're starved of star-making gases. But people think this, but most scientists today believe that large spiral galaxies and spiral galaxies like our Milky Way are just born that way. So 4.5 billion years ago, and this is where our solar system enters the universe's book, is that our solar system was born 4.5 billion years ago from a nebula. It may have looked something like a huge, reddish, cold disk of gas and dust. That gas and dust was once used in the life of a star before it. The stars have this thing like a phoenix. They lose everything and they start over. So the center of the core ignites and a star is born. It's our sun. So for the first few million years, things ran smoothly as objects started snowballing into heavier objects. And once these objects got sufficient gravity, they began pulling each other into crossing orbits, sometimes colliding with each other. How do we know this? Is because we can tell from our solar system's age is that the comets and asteroids tell us a violent past. Is that Earth and the other planets were forming. So the interplanetary system, all these little planetesimals and bodies, including Earth, they had no stable orbit. They were going in, like, some were going in this direction, some were going in the other, and once in a while, they collided. So our Earth actually received such a smash-up a billion years after its birth, when a Mars-sized object that scientists call Theia slammed into the Earth. This collision should have destroyed our planet, but instead, Earth survived. And it also created our 24-day axis and what caused us to have seasons. The material caused from the collision caused a huge part of the Earth's mantle to be thrown out into orbit. This formed a ring, not like Saturn's rings. Most of the material fell back to Earth, but a couple of shards still remain. These coalesced into the moon. This is how our moon formed. It's unusual to find moons in our inner solar system. Mars has 2 little asteroid moons, and Earth has 1 moon. And so, without Theia, we would not be here. Earth would not have this gravity. This collision also allowed it to become the largest of the terrestrial planets, allowing it to have a bigger iron core. And so Thea's core merged with that of Earth. The reason why we don't see that crater today is because it was filled up with the debris, and Earth is constantly reshaping itself. It's sucking all the old material back into its mantle, and it's erasing all its traces and beginnings. Our sense that the Earth is stable is an illusion caused due to the shortness in our lives. But if we were able to watch the planet on its own time scale, we could see it not as a ball of rock, but as a living organism. Billions of years later, after its birth, Earth began to cool at the surface, but its core remained as hot as the surface of the sun. Molten rock from the core of the Earth made its way to the surface, where it began creating these hydrothermal vents. Asteroids were still bombarding the Earth, and comets were as well. But these volcanoes also spurred out the ingredients for water. Half of the water we have today, in the polar ice caps, oceans, and every other source of water, including the groundwater we drink, all had their beginnings in either asteroids, comets, or the volcanoes. So over time, rivers formed. They began filling the deep areas of our planet, creating its oceans. It was starting to look like the world we call home. But it was still a hostile place. The Earth had no oxygen atmosphere like we have today. It was a witch's brew of sulfuric acid, carbon dioxide, some nitrogen, lots of methane, no oxygen. That would come much later. But even then, in a hostile environment, life had taken hold. The first type of life that inhabited our planet was simple microbial bacteria, like primitive viruses and primitive bacteria. They made a living in hydrothermal vents at the bottom of the sea. Life probably came to Earth as formed from amino acids in meteorites and comets that revived. As they decomposed on the ocean floor, the oxygen inside them and the amino acids inside them got out of them. And so, for billions of years, simple molecular life, microbial organisms, were the only kind of life that evolved. And for billions of years, that was the only life that was here. But around a few billion years ago, change was on the way. And life could now get a little bit larger. You can actually see this life still in Shark Bay, Australia. You would see these weird mounds. They look like rocks or plants. These ones dominated the Earth's oceans. They're called stromatolites. And as alien as they look, all of us, you and me, all our animals, our dogs, our cats, every single form of complex life owes their existence to them because they made oxygen. For them, it was just a waste product, but for us, it was the breath of life. They took in carbon dioxide and mixed it with sunlight in the process called photosynthesis. And it was actually only the outer part of them that was alive. For billions of years, they dominated the planet, and the oxygen was going into the atmosphere, mixing with ultraviolet radiation, creating the ozone layer, the natural sunscreen that protects us from the sun. But deeper in the ocean, some of the iron left over that was exposed met the oxygen. It escaped. But the H2O molecules bonded with the iron molecules. And this rust created iron ore. Most of the iron ore in our skyscrapers and mined across huge quantities commodities in the world was made in oceans billions of years ago. This iron kept a lot of oxygen, but the iron itself was going back into the earth, taking some of the oxygen with it. So when there was no more iron, the oxygen started escaping into the atmosphere, causing it to build up. Billions of years later, some rocks and our continents started colliding together. The first continents were little tiny islands, like the Hawaiian Islands. They started erupting out of our planet's ocean. They looked like little polka dots on our planet. So they started colliding and forming the continents. So these continents, as they grew larger, they began colliding. And so they split apart after a while, and rocks were exposed. And these rocks took in trapped carbon dioxide that was produced by volcanoes. There was not enough carbon dioxide holding the heat. And so it began the age of snowball Earth. There is evidence for this catastrophe. When there was not a lot of carbon dioxide left in the atmosphere, it started getting cold on our planet. Huge glaciers formed for the first time. They were probably several stories high, probably thousands of feet high, and they began covering our planet, starting at the poles, and they began working their way slowly over thousands of years, eventually entombing our planet like an icy ball. So every time the sun was trying to warm the planet, the ice kept reflecting almost all of its heat back into space. It seemed nothing would save the planet from a frigid death. But even that seemed far-fetched. For a few billion years, it seemed that the ice had taken hold forever. But deep below, the volcanoes that were erupting were starting to launch revenge. They began pushing their way out of the ice, and they created terrifying scenes, and they started spewing carbon dioxide into the atmosphere. Never to compress the history of the universe into a year, we humans would only be like the last 2 seconds on the cosmic calendar. So we're like the newest invention of nature. To us, like 4.12 million years seems like a long time, but that's only a fraction, that's only a trillionth of a second. But still, in the eyes of the cosmos.
How did we actually come about that? How were we created?
If you believe in the biblical record, that's fine. But in the eyes of science, we evolved from apes. Literally every complex land form evolved from fish. You want to know what fish evolved from? Bacteria. And primitive backboned animals.
Very nice, thank you.
It was basically caused global cooling. Today we're used to global warming caused by us burning thousands of pounds of coal that was once wood and trees during the Carboniferous period. I'll get to that, and I'll start again where I left off in my next lecture. And that is causing global warming. But we're not paying attention to any other sources of fuel. But back during the time I was talking about, the carbon dioxide was like being absorbed a lot by those rocks. We don't know what type of rocks they were. Probably scientists do. But whatever type of rocks they did that took in those carbon dioxide, they did a good job in causing our planet to go into the most catastrophic ice age ever. The ice age that we all know all about, that's the most recent one. Earth has had many ice ages in its past, not just one.